Hello. So today we are going to discuss chapter measurement from grade 6 physics. So can you tell me in this two line A and B which one is longer? Okay, you might feel that the line B is longer. Okay, let's see another example. We have two glasses with juice. Can you tell me which one has more juice? So it's not very convenient to looking at the objects to see and tell like which object has the more juice or maybe which line is longer. Now in our first example, if you see, actually both the lines are equal. So line A and line B are actually equal. Now in the second example, it's not easy to tell which glass has more juice because the size and the shape of the glasses are different. So now let's see what is a measurement. So measurement means when we compare the physical quantity of within of an unknown physical quantity with a known physical quantity. What does that mean? Now look at this pencil. If we want to measure this pencil, this is an unknown physical quantity. We don't know what is the length of this pencil. So if you want to know the length of this pencil, we have to use a ruler where the quantity of this ruler is fixed. We know that here it is 0, 1, 2, like that. It is going from 0 to 1, 2, 3, 4, like that in millimeter. So if we want to measure this pencil, we are going to compare this pencil with a fixed standard quantity. This comparison of quantity is called a unit. Now let's see more about this. Okay, now what is a physical quantity? A quantity that we can measure is called the physical quantity. Now here in this case, this pencil is a physical quantity because we can measure the length of this pencil. Like that, time, volume, temperature, all these are physical quantity. Now, what are the types of physical quantity? So basically, there are two types of physical quantity. One is known as fundamental physical quantity. And what is a fundamental physical quantity? Like, if we want to measure the length of this pencil, now this is a fundamental physical quantity. We can just directly, measure the length of this pencil by using a ruler. Like that, mass, length, time, temperature, etc. are fundamental physical quantity because we can directly measure all these objects with the help of a ruler or maybe a thermometer or a watch, like that. Now, what is in derived physical quantities? Derived physical quantity means when we combine two or more fundamental quantities to obtain a value. Now, what does that mean? Let's say we want to find the area of a square, right? Now, to find the area of the square, you need length and the breadth. Without both length and breadth, you cannot find the area of the square. In the same way, if you want to find the speed, then we need distance and the time. So if we want to find the speed of a vehicle, we need distance and time to find that. So basically here, to find the value of speed, we need two values. One is distance and one is time. So based on those two fundamental quantity, we are going to find the value of speed. So this type of quantities which we find based on two or more fundamental quantities, we call it as derived physical quantity. We will learn about this later in our later slides. Now, let's see, why do we actually need, standard unit of measurement? So in ancient time, people used to, measure with their footstep, arm length. So this is called 1 cubit. So this one arm length, we call it as 1 cubit. So this is, we call 1 handspan. Like that, ropes, stakes, etc. We in ancient times, people used to take to measure length. But because this way of measurements are not fixed, so measurements of the same object varies from person to person and place to place, and which was not very convenient and it was not even accurate. Because of that reason, we started with a standard unit of measurement. To solve that problem, we accepted a standard unit of measurement all over the world, right? Now, there are three fundamental quantities: length, mass, and time. So based on these three fundamental quantities, we have three systems. The first one is MKS. The meaning of MKS means meter, kilogram, and second. Second one is CGS. The meaning of CGS means centimeter, gram, second. And the third one is FPS, means foot, pound, and second. Now this is a simple table where the MKS system, so where MKS, CGS, and FPS systems were described. So for length, in MKS we use meter, CGS centimeter, FPS foot. For mass, we use MKS kilogram, CGS gram, and FPS pound. For time, we use MKS second, CGS second, and the FPS also second. Out of this three system, MKS is the most widely used system. Okay. The unit that could be used everywhere as a base unit of measurement is called the standard unit. Now let's see how we write a measurement. So a measurement consists of two parts. One is the magnitude. So magnitude is nothing but the number, right? And the second part is the unit. So unit is nothing but the either kilogram or meter or second or centimeter. It can be anything. Okay, so this part is called magnitude and this part is called unit. So any measurement consists of two parts. First part is the magnitude, which is the number, and second part is the unit, which can be anything: gram, kilogram, meter, centimeter, second, anything. So basically, when we write a measurement, it consists of two things: n times u. So where n is the number and u is the unit. And this gives us a physical quantity Q. So this is our physical quantity Q, right? So fundamental units of SI. So what does that mean? Fundamental units of SI means International System of Units System. So units which we use to measure fundamental quantities are called fundamental units. Now you know what are fundamental quantities, right? Fundamental quantities are when we try to find the measurement of a length, mass, you know, time, temperature. These are all fundamental quantities. So there are 9 basic fundamental units of in SI system. Let's see what are they. So for quantity, so this side we have all the quantity, this side we have all the unit, and this side we have all the symbol. So for length, it is meter, and we write it as small length. For mass, it is kilogram, we write it as kg, small kg. For time, we write it as second and we symbol it as small s. For temperature, it is Kelvin and we write it as capital K. We will learn about the symbols in our next slide. Current, ampere, and we write it as capital A. Luminous intensity, we write it, the unit is candela and we write it as capital C and small d. Amount of substance, we write it as mole, and the unit symbol is mole, MOL, small letter. Angle, we write it as radian, and it is RD. Solid angle, it is steradian, and we write it as ST dash RD. Now let's learn about the symbols in little more, okay? So there is some convention of writing these symbols. So symbols we use for the units are always used in small letters. We never write capital K and G. We always write small kg for kilogram. In the same way, we write small m, not capital M for meter. In the same way, we write small s, not capital S for second. Symbol of unit, which are named after scientists, always written with a capital letter. Now, Fahrenheit, we write it as F, capital F, not the small f. Ampere, we write it as capital A, not small a. Newton, we write it as capital N, not small n. Kelvin, we write it as capital K, not small k. Now, symbols are never followed by full stops. Fahrenheit, we write only the F, not F and full stop. M, not M and full stop. Kg, not Kg and full stop. But we can use a full stop if the unit is written at the end of the sentence. Let's learn few more convention. So symbols for units remain unaltered in the plural. That means when you have 10 kilograms, we write it as 10 kg, not 10 kgs. When you have 20 meters, we write it as 20 m. We don't write it as 20 ms. Now, if we are writing the full form of a unit, then we start with a small case. We do not start with a capital case. Like when we write Kelvin, we write it as small k. We start the letter word Kelvin with a small k, not with a capital K. When we write meter, we don't start with capital M. When we write Newton, we do not start with capital N. When we write Celsius, we do not write with capital S. Okay, now here, don't get confused with Kelvin, Newton. Only when you are writing it in the short form, we write the capital K, capital N. But when we are writing the full form, we start with a small k, small n. Hope you got the difference. Now, when we divide one unit by the other, we use negative power. Now, what does that mean? Okay, let's learn about that. Okay, so the unit of speed is meter. So the formula to find speed is meter by second, right? First, let's see, the formula for speed is meter by second. So meter means m, the unit for meter is m, and the unit for second is s. Now, how do we write this? We write this as m. So it is nothing but m times 1 by s, right? So when we have a fraction format in this way, you might have already learned it in exponents. When we have a fraction something like this, if we take the denominator up, then our number is become 3 to the power minus 1. So same thing applies here. When we take this as 1, this becomes power minus 1. So when s to the power minus 1 is there, that means it's nothing but m into 1 by s. So 1 by s is equals to s to the power minus 1. I hope it's clear. Now, what is the multiple units? Okay, so we know the unit for length is meter. But if I want to measure the distance between two cities, are we going to use meter to measure it? It's going to be very, very inconvenient if we have to measure the length between two cities or the distance between two cities with meter, right? So what we do in that case, we use kilometer, right? Now, kilometer is a multiple of meter. Now, what does that mean? In 1 kilometer, there is 1,000 meter, right? So that means 1 kilometer is equals to 10 to the power 3 meter. Now, what is meaning of 10 to the power 3? So 1,000 means 10 times 10 times 10, right? So if you multiply 10 times 10 times 10, which is 3 times, if you multiply 10, you get 1,000. So which is nothing but we are multiplying 10 for 3 times and we write it as 10 to the power 3. So when we use a bigger unit to measure something, that time we multiply our unit of measurement, unit of length, here in this case unit of length, we are using the multiple of unit of length. So that is why it is called multiple units. Now what is a sub-multiple units? Let's say we want to measure the length of an eraser or pen. So how can we use a meter in this case? As our SI unit for length is meter, but it's very inconvenient to use a meter to measure a eraser. So what we can do? We are going to use centimeter or millimeter or decimeter, which is a sub-multiple of meter. Now what does that mean? So 1 meter is equals to 100 centimeter or 1,000 millimeter. So that means we are this time dividing 1 meter into smaller parts, into smaller unit, which is either centimeter or millimeter or maybe decimeter, to measure the length of our object. So when we use smaller quantities than the standard one to measure something, we call it as sub-multiple units. Now these are few submultiple units for length, submultiple and the multiple units of length and mass. So if you see on this table on your left hand side, 10 millimeter is equal to 1 centimeter, 10 centimeter is equal to 1 decimeter, 10 decimeter is equal to 100 centimeter, 100 centimeter is equal to 1 meter. So in the same way, we have multiple units when 1000 meter equal to 1 kilometer, then 10 millimeter is equal to 1 centimeter. In the same way for mass, we have sub multiple units as 10 milligram is equal to 1 gram, 1000 milligram is equal to 1 gram, 1000 gram equal to 1 kg. In the same way, 100 kilogram is equal to 1 quintal, 10 quintal is equal to 1 metric ton, and 1000 kg is equal to 1 metric ton. Now, these are just some of the units we are going to use in our future. So now we have already discussed a little bit about derived units. Let's look at it again. So derived units are those fundamental units which are not sufficient to measure. Why we use actually derived units? Let's first look at this. So we cannot, measure everything, every quantity in science and technology only by using the fundamental units. And we need to, combine two or more fundamental units, measurement of units, to find the value of other specific units. So in that case, we need the help of derived units. As I have already discussed, to find the area, we need the length and breadth both. Otherwise, we cannot find the area of that object, right? Or shape. So to find the area of an object, we need L, which stands for length, and breadth, which stands for P. Now both this L and M should be in the same unit. Okay, so then we multiply both the units, and which will give us the, here in this case we don't have, let's take an example. Okay, let's say we have L into P. So let's say we have our L as 5 meter and our P as 4 meter. So to find the area, we will be multiplying 2 times 4, which is 20, and then meter into meter, which is become meter square. So 20 is our magnitude, the area of this field, and meter square is the unit for the area of that field. So, or that shape. So 20 meters square. So this is our magnitude and this is the unit. Let's now see. So these are the different formulas we use to measure physical quantity. So we have first column physical quantity, second column the formula, third column the derived unit we get, and this fourth column the symbol we use. So for area we use length into breadth, which is meter into meter, we get meter square. For volume, length times breadth times height, so we get meter into meter into meter, we get meter cube. For density, it is mass by volume, so which is kilogram by meter cube. So we write it in this way, either kilogram by meter cube or kilogram into m to the power minus 3, because meter cube is our at the denominator. Now for speed, it is the formula is distance by time. We write it as meter by s, which is m by s, or m into s to the power minus 1, because s is on our denominator. Acceleration is the change in velocity and change in time. So this is the formula, m into s to the power minus 1 by s. So now here, if we take this as up, So it will become m into s to the power minus 2. Force is meter into acceleration, which is again kg into meter per second, meter per second square, and this gives us the symbol Newton. Velocity, displacement by time, which is meter by second. So it's the formula symbol is m by s or m into s to the power minus 1. Work is the formula is force into displacement, which is Newton into meter. We symbol it as joule. Power is work done by time, which is joule by s, which is watt. Potential energy is mgh, which is kilogram into meter by second square into m, which is again joule. Kinetic energy is half of mv square, where kg into m by s whole square is our derived unit and symbol is joule. Now, we are not going to use all these formulas now, but for your reference, I have just showed you what are the different formulas and the derived unit and symbol we have. Now, these are the questions from this chapter, the exercise. So few of the things you'll be able to answer by if you'll go through the slides and the explanation part. And few of the question answers has been given here. You can just go through it. And also few questions you'll be able to answer by going through the slides and the explanation part. But still, if you have any doubt, you can post your question from our contact us form and we will help you with the answer. I hope you have understood the part 1 of the measurement. Next, we are going to take care of the second part of the measurement, like measurement of length, area, volume, and mass. What are the types of devices we use? All these things we are going to take care of it. Please go through your slides from the measurement chapter here. And if you have any doubt, please don't forget to contact us with your query. We will be very happy to help you. So for references, we have used internet and concise physics book by Selena. Thank you.